Okay, so we're moving on to the graphical model. So what we did last chapter is the algebraic model. So we were solving all kind of equations, right, using algebra. So moving things around and solving. In this unit, we're going to learn how to graph data and how to solve for a certain data using the graphs. So we're going to next, as of tomorrow, we're going to go to the MATLAB to 103, I think, and then we're going to be using the computer. Okay, we're going to use Excel. We're going to graph using Excel, and then we're going to find regression. Okay, so that's the plan for this chapter. Okay, I don't do any graphs by hand because when you get to college, you are not expected to do it by hand. They expect you to know how to use one of the things, like Excel. Excel will be the top one that they would want you to use, and they expect you to know how to find the regression line using Excel. Okay, so that's one thing that I want to get you ready for college for. Now, a graph is a visual representation of the relationship between two quantities. So, every time you see, like even when you're looking at commercials, or when you're looking at the stock market, right? Or when you're looking at things where they want to catch your attention and they want to give you a lot of information in one slide, they will do it as a graph, right? When they're showing you polls, when they're showing you like there's way too many things to think about. But instead of writing all the information down as paragraphs, just a simple graph would be enough to show people what the message is, right? So it's a visual representation of the relationship between two quantities, right? We have X and Y. We always have two quantities, one on the Y-axis and one on the X-axis. It shows how one quantity changes with respect to the other quantity. Now, which one is your dependent and which one is your independent? That's right, X is your independent. So you always plug in values of X, and then Y is going to depend on X. So you always put your independent on the X-axis, and then you put your dependent on the Y-axis. So we're going to have different types of graphs, right? We have seen, if you took the grade 10, you probably have seen the linear graphs, right? If you have taken the grade 11, you have seen the quadratic graphs, right? If also in grade 11 you see exponential graphs. So there's different functions, different relations. They have different outcomes, okay? They're not the same. So let's look at the relationship shown and then we're going to describe what we see. So what we have in the first example, we have Jack's babysitting. So how much does Jack earn for every hour of babysitting? He does, right? So what kind of relation do we see here? Linear relation, right? It's a line. If you look right here, that's a straight line, right? So that's a linear relation. And it's a linear relation because for every hour he earns, he's going to earn an extra whatever amount. So let's say $40 an hour. If he works 1 hour, he's going to get paid 14. If he works 2 hours, he's going to get paid 28, right? So his rate is going to be going up constantly, right? Constant rate. It's not like if you work more than 5 hours, you're going to start getting paid $20 an hour. No, it's a constant rate. 10 hours, you get paid $14 an hour, so that's $140, period. Make sense? So this is what we call a straight line, right? Now if you look here, his earnings depend on what? The hour works. So the hour works is independent. It depends on, well, there's no limit to how many hours he can work, right? Technically. but his earning always depends on how many hours he works, right? And we see a constant rate and it's increasing, right? So the more hours he works, the more money he's gonna make. His earning increases by a constant amount, and that's very important, and that's why it's a line. It's a straight line, because it's increasing by a constant amount. So for the second scenario that we have, it's the amount of compound interest investment. So what do you see here? What is it? Exponential graph. It's not a straight line, right? If I'm going to graph a straight line here, it's going to look like this. This is nothing like a straight line, right? So what do we see here? We see kind of a small increase at the beginning, and then it increases faster, right? So we've seen exponential in the previous unit, right? This is how the graph looks like. All right, so why is this an exponential increase? So we're talking about compound interest. Do you guys know what the word compound interest is? Compound interest is when you're earning interest on the interest that you have. Okay, so there's two kinds of interest. You have the simple interest and you have the compound interest. We're going to talk about them in the next unit. A simple interest is when you have just like basically every single time you earn interest, it's going to be exactly the same amount. So let's say you have $1,000, you put it in the bank gives you 10% on it. Yeah. They give you 10% on that $1,000 every year. So every year you're gonna get $100. No matter how much money you have in your account, right? You're still earning that $100 every year. It's not gonna increase, it's not gonna decrease, it's gonna be $100. Okay? Now with a compound interest, on the other hand, you're earning, let's say 10% compounded annually, then after the first year, you're gonna earn $100, right? First year, 10%, you're gonna earn $100 on the 1,000. Make sense? On the second year, you're gonna earn interest on the 1,100 because now in your account, you don't only have 1,000, you have $1,100. So the interest that you're gonna earn is on the interest as well. So instead of earning only $100 interest, you're gonna earn $110 interest for the second year. The third year, you're gonna earn on the $1,210. Okay, so your interest is gonna keep accumulating because you have more money in your account, you're earning more interest. Does it make sense? So, in the case of a simple interest where every year you earn the same amount, it will be a linear function, right? But in the case of a compound interest, on the other hand, you'll have an exponential function. At the beginning, you're going to earn 100, then you're going to earn 110, then you're going to earn 100 and whatever, $11 or whatever. I don't know, I'm doing the math right now. And then it keeps growing. Okay?
That's because the rate is not constant.
That's because the rate is constant, but the amount that you have in the bank is not constant. Okay? So yes, your interest is not constant. So the amount of the compound interest investment increases over time. So at the beginning we have a small increase, so slowly increasing at first, and then very
I don't forget what.
Okay, are we okay with this? The graph for this one is wrong, so I'm gonna just change that. And that's gonna be temperature. So you have a cooling cup of coffee. So you make your coffee, it's boiling hot water, you let it sit in the room. What's gonna happen to it? It's gonna cool down, right? It's gonna cool down at the beginning because of the room temperature is like 20 degrees. Let's say the coffee cup is about 100 degrees. What's gonna happen is that it's gonna cool faster at the beginning, but then when it gets to like 20 degrees or 25 degrees or wherever the room temperature is, you're gonna see a very slow decrease, right? Because when it gets to the room temperature, it's not gonna get colder than the room temperature. Okay? So what we see is at the beginning we're gonna have a fast decrease in temperature, and then it's gonna slow down as the coffee cup gets, the temperature of it gets close to room temperature. Should drink my coffee before it gets to that point. So again, this is an exponential, right? But it's an exponential decay. We see a decrease, right? So the coffee temperature decreases over time.
So what do we call that kilogram?
Exponential.
And the one before was?
Exponential as well, but the other one is exponential growth. This is exponential decay. Are we okay with this? So what we see here is that if you're gonna take the slope, right, at certain points, you're gonna see that the slope is decreasing fast at the beginning and then it's slowing down. It's becoming more horizontal as you get closer to that
word after finally?
Finally leveling off at temperature. Alright. Can I go to the next page? Okay, so fertilizing a field. Can you guys look at this, tell me what you see, and then tell me why you think that is? What happened in the beginning? It went up? Then what happened after that? Went back down. So it reached a maximum and went back down. Can you tell me what kind of function that is? When it goes up, reach a maximum and then go back down? It's a parabola, quadratic, right? So it's a quadratic. So we have something, a shape that looks, yes, you don't have the other part of the shape, but it should look like this, right? Where you have this kind of shape. Alright, now, parabola, quadratic. Parabola is a shape, quadratic is a function.
Can you explain that to me?
Yeah. Quadratic is a function. Okay, now what do you think that is? So think about what do we have? I have fertilizer used on the x-axis. So the more fertilizer I use, what's going to happen to my crop? So it's gonna grow, right, to a certain point, and then what happens after that? It's gonna kill them. It's gonna start killing them because it's gonna burn. You're gonna burn. That's right? So you have to be careful how much fertilizer you use. You don't think if you use more and more fertilizer, you're gonna have more and more yield. To a certain point, yes, you're gonna get to that maximum amount of yield, right? And then after that, you're gonna start killing the plants. So you're not gonna have a lot of yield. So what we see at the beginning, we see that it's increasing to a certain point, to a max, and then the yield started to decrease. Okay? So as fertilizer use increases, the crop yield also increases to a max, and then decreases. Are we okay with this? Alright. So we're going to move to what we call transient graphs. So transient graphs are basically, it shows you a pattern in the graph, right? So what's happening, right? So I can sit down and write down what is happening between year this and this, year this and this, but it's simple if I show you a graph, right? And you'd be able to visually see, right? You have to know how to read a graph. So, looking at this graph, so this is a trend which shows the, what did I say, patterns of change. And a lot of time, in order for like the government, for example, to make decisions, or let's say if we're looking at hospitals or we're looking at school boards or whatever, they look at trends in the graph, see what's going on, see, like, let's say, if we're looking at a board, right, and they see that their enrollment is increasing every year, they probably want to open more schools, or they probably want to hire more teachers, or they probably want to have more supervisors, or whatever, right? So they have to look at the trends, what's happening in their enrollment, in order for them to be ready for it, right? And this is in any job that you do, right? Any job that you do, any company and thing, they always look at graphs, look at trends, what's happening and what can we do. If they see things are starting to go down, they're gonna have to start saving money somewhere, or they're gonna have to start cutting out people and so on. Okay? So if we're looking at this graph shows the number of births in Ontario from 1945 to 2005, and it's asking to describe the trend in the graph. That S should be with a trend, and then it the S should be with a trend. So when you're looking at graphs, you have three different options. It's either increasing, decreasing, or constant, right? Stay the same. So you have either increasing, decreasing, or constant. Now, what I did here for you is I've already kind of split it down into the increasing, decreasing, or constant, right? So you see that from 1945 to almost 1960 to 1960, we have an increase, so I split it for you, okay? And then it started to decrease, so I split that, and then it's kind of constant, I split that, and then increasing, I split. So I already split that for you, okay? But usually when you're looking at a graph, you want to do this. You want to look and see, okay, I have an increase, okay, now I'm starting to decrease, so I'm gonna split my graph here. Make sense? And then you're gonna look, okay, decreasing, decreasing, decreasing. Okay, now it looks like it's leveling off, so I'm gonna split my graph. Okay? All right, so 1945 to 1960, what do we have? As increase. How is the increase looking? Is it looking fast at the beginning and slow, or is it looking slow at the beginning and then fast, or is it constant all the way?
Slow at the beginning.
Slow at the beginning,
Fast in the middle.
and then get faster, right? Yes, you're right. Between 1950 and 1960, we had a huge increase in Ontario population in birth, right? And that is known as what era was that? The baby boomers? Yeah, baby boomers, and between 1950 and 1955. And then it's a kind of a slower increase, but it's still an increase, right? But it's half of what it was in the 5 years prior to that, right? So, let's write that down. So from 1905 to 1960, we're going to say that the number of births rapidly increased to a maximum of 160,000. So that's every year they had 160,000 births in Ontario. Rapidly increase to a max of 160,000. And then what do we have after that?
Slow decrease.
We have a decrease. It's a slower decrease, that's right, but it's still a decrease, right? And it's a decrease after that. So the number of births decreased. Actually, at the beginning it's rapid, right? Because you went from 1960 to 92, sorry, from 1600 to from 160,000 to 140,000 within 5 years, right? So the number of births decreases. Rapidly, then slowly. And then more rapidly. So we see that in between I want to say 1965 and 1970, right? That's a very slow decrease, like it's barely decreased, right? But it's still a little. What happened between 1975 and 1980? It was constant. There was no decrease or increase. It stayed the same, right? So, so the number of births are constant. No change. How about between 1980 and 1990? Increase. Can you describe the increase for me? Slowly at the beginning, right? It barely increased at the beginning between 1980 and 1985, but then we see a jump, right? A rapid increase between 1985 and 1990. Now, can you look at the other two sections and what do you see? What do you see? Decreases. So it decreases slowly, then rapidly, and then increases slowly, right? Okay. So I'm just gonna, because I'm gonna go back here and write it. So number of births. Decrease slowly, then more rapidly later. And then number of births increases slowly between 2000 and 2000. What is it?
Birth decrease slowly, which one of the
That's 2000 and 2005, so that's F. That's the last. It's right here. Right? You have the graph that we were using earlier. Right? So if you look at F, right here. Okay, so this is basically, I'm looking at trends in graphs, right? So I'm looking at the graph, and I'm kind of splitting it down into like different portions, increasing, decreasing, or constant, and then I'm talking about it. Okay? I can also use graphs to predict what's going to happen in the future. Okay? Now that is, the prediction is always doesn't have to always be correct prediction, right? Because we never know what happens. Something might happen and then things crash or whatever, right? So you can predict, but it doesn't have to be, the prediction doesn't have to be 100%. So what we have here, we have a graph to predict the number of Canadians in each age group in 2010. So they gave us a graph, and the graph is the number of people in millions and the year, and that's for people, the Canadian people, age 80 and over, age 60 and over, and age 15 and under. Okay? So can you guys describe to me, what do you see in the age of 80 and over of Canadians? Slowly increasing, right? And then can you tell me why that might be? Why is the number of 80-year-olds is increasing slowly in Canada?
So there's already people that are 80, and then there's people who are the 60 and over people eventually, when they get to their 80s, that also goes up.
But why there's less people in the 1970 that were 80 years or over, but now we have more people who are 80 and over? Better healthcare, right? There is better research, better healthcare. There is more people now. Government did something so they can afford medication, right? So they live longer life, right? There's not a lot of war, right? So there's more people living to beyond 80, right? Before it used to be like a long time ago, the expectation, the age expectation was like 60 years old, right? Now it's like 80 plus. Okay, so it's all for better healthcare, right? More affordable like healthcare for the people, especially in Canada, and also better living, right? There's no war, there's other things.
Nutrition too.
Right, nutrition. Yeah. Okay. Now, what can you tell me about the age 60 and over? Increasing. I see fast. Like I see that's a huge increase, right? And that's because the baby boomers, right? There is a lot, and we see from the previous graphs that people who were born between 1960 and 1950 and 1960, there was a lot of birth, right? And then if you're thinking about it, 1950 to 1960, they're about 60 years old now, right? So that's why there's an increase, because the baby boomers are now 60 years old, right? Make sense? So there was a lot of birth in that year, in that era, in that decade, right? And now we're seeing them, they're all like retiring, they're all like, right now they're all in between 60 and 70 years old. Okay?
Why do you say it's increasing fast? Like,
Why is it increasing fast?
Why is like, according to how the line looks?
Well, think about it this way. That's from that's about like 22,500,000 to about 5 million. They doubled. This is not, yes, the number might look small to you because it's 2.5 to 5, but that's million of people, right? So they doubled from 19 So people who lived in 1970 who are 60 years and over, right, there was only about 2.5 million. But now, in 2000, there's about 5 million who are 60 and over. Okay? And the reason of that, better healthcare, number one, less war, number two, right? Because a lot of time, like if you have war, a lot of people will die, right? Especially people who are fighting and whatever, right? And then we also have the baby boomers are now 60 years old. Okay? What do we see about the age of 15 and under? It's like decreases and then increases, right? So you have a decrease and an increase and an increase, like it's fluctuating, right? And the reason for that, if you look between 1970 and about 1985, right? It's decreasing, and that's because the war, right? There was war, there was not a lot of people having children, right? And then after that, we have an increase, and that's in the like 1990s, right? Everything was fine, right? We have an increase a little bit, but then the trend is that it's gonna keep decreasing. People are getting married later in life, right? They're not getting married early. They're not having a lot of children. They'd rather do their look after their careers first, and then once they're 35, 36, 38, they get married. At that age, they're not gonna have that many children, blah, 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 like all of this, right? So it's all affecting the number of our youth. So if I look at this trend, as you can see, the red dotted line is the line that I have extended. So we call this an extension to the graph. The graph was given to us up to 2000. Okay? Anything after 2000 is kind of a prediction. Okay? So we're predicting that the number of people who are 80 and over is going to keep increasing at the same rate. Okay? We're predicting that the number of 60 and over is going to keep also increasing. Predicting that the 15 years old and younger is going to keep decreasing. Right? So this is called prediction. Okay? So in 2010, if I'm going to look at this, in 2010, which is going to be right here, how many 80 and over am I expecting to have? Around a million, right? So from my extension of the graph, I can say that I will have about a million 80 and over. This means about, so when you write an equal sign with a dot on top of it, that means about. People between 60 and 80, what do you expect? Around 6.2 million? There's even more than 15 and under, huh? And in 2010, how many 15 and under do you expect to have?
Around 5 million?
Yep. So this is what the government will look at. The government is going to look at this graph, and that will be in 2000, and the government's going to look at it. And then the government's going to have to make decisions, right? What should I do in order to make sure that whatever prediction I have, I'm ready for it, right? So what do you think the government of Canada should have done, like in 2000, if we are right now in 2000, and we are the government and we need to make decisions on, so we're ready for the prediction. What would we make? What kind of decisions should we make? There's going to be a lot of people retired. So in order to accommodate for that, what should we do? Get ready for that, and then get ready for more retirement homes. That's right. What else? advertise for jobs. In order to advertise, but we need people who can actually work in these jobs. So what can we do?
Have more programs for dealing with the elderly.
Okay, so we need to have more programs for elderly, but how can we increase the number of youth instead of only, yes, we're planning so our adults or our elderly have plans in 10 years, but also we have to improve, right, the number of youth that we have, because the youth, when these people get to the age of 60, right, the youth are going to be working, right? Whoever is 15 right now, they're going to be working in 10 years, correct? Because they're going to be 25. Who's going to pay for the elderly retirement? The youth, because they're the ones who are paying taxes, right? So if I don't have enough youth or enough people working to pay taxes to pay for the elderly, the government's going to go broke more than it is right now, right? So the government has to do something. They either have to help parents right now in 2000, right, to have more children somehow, right? Either give them free daycare or give them money for having more children, or it's not that. If you don't want to help people to have more children, you probably want to open immigration for families, right? Young families, let them come in, right? So when you bring immigration of young families with people aged 10, 15, 20, right? 10, 15, all right? Then when they come in 10 years, you're gonna have more people who are ready to work and ready to pay taxes. Hopefully, right? So you always have to kind of think ahead and predict what might happen and how can we fix that. Okay? You have to improve your health care, because you're gonna have a lot of elderly people who needs medication, who needs hospitals, who needs nurses, who needs whatever, right? So we need to work on that. We need to make sure that our hospitals are ready to have this many people, right? We need to make sure that there is more immigration, but we have to pick who we immigrate. We don't want people who are gonna be 80 in 10 years or 60 in 10 years. We want young families with children, right? And we have to kind of help people who live in Canada already, who are having children, you know, have more children. We're gonna help you. We're gonna do this, okay? Because the children are gonna be your working adults in 10 years, right? So these are the things that the government will look at, and these are the things that the government will try to work on in order to be able to. Make sense? All right. So I'm gonna go to this, but I'm gonna stop this first.